welcome to my channel. So here is the question of Bernoullis differential equation. dy by dx minus tan y by 1 plus x is equal to e power of x 1 plus x sec y. So for this we have, as you know, the Bernoullis differential equation formula is dy by dx plus py is equal to q y power of n. Okay, so this part is the q, this part is y power of n, and this whole part this p means here we have 1 by 1 plus x, and y means this tan y term. Okay, and dy by dx. So we have to remove this y part. Okay, so for this we have to divide by sec y on both sides. So we suppose this is equation 1. So we have divided by y on both sides on equation 1. So it becomes 1 by sec y dy by dx minus, and here is 1 by 1 plus x and tan y by sec y is equal to, it becomes e power of x 1 plus x. Is sec y by sec y cancel out. Okay, so we can write this term as, so 1 by sec y means cos y dy by dx minus 1 by 1 plus x. As you know, tan y means sin y by cos y, and here we have sec y, so we can write this sec y as into cos y. So this and this cancel out, so we have the remaining term is sin y. So here is as it is 1 plus x. So suppose this is equation 2. Okay, so now suppose this term, so this y term is b. Okay, so for this put sin y is equal to b. Then we have to differentiate this term with respect to x. Okay, so db by dx is equal to d sin y by dx. We have to perform d sin y by dy into dy by dx. So the differentiation of this is cos y into dy by dx. So we have db by dx is equal to this term. Okay, so here in the equation 2 we can see cos y dy by dx means, so db by dx, we can place this term. So equation 2 becomes, so we can write this as db by dx minus, and here we can see we have suppose sin y is b. Okay, so 1 by 1 plus x dot b is equal to e power of x 1 plus x. So here we suppose this is equation 3. As you can see, this equation is in the form of linear differential equation. That is the equation we have to compare this with dy by dx plus py is equal to q. Okay, ignore this negative sign at this moment. So here we have comparing equation 3 with, so as here in the term, this equation is in the term of y and x. Okay, so as here we have db by dx term, so we can write this as with db by dx plus pv is equal to q. Then here we obtain, so db by dx, in the p term we obtain p is equal to, here we have minus 1 by 1 plus x. Okay, so here is sign minus, and in the q part we have e power of x 1 plus x. Okay, so now is equation 3 is linear differential equation of first order. Okay, so its integrating factor, that's if is equal to, we have the formula e power of p integration of dx. Okay, so now we can write this as e integration, and here is we have minus 1 by 1 plus x, and in the here we have dx. So as you know, d log x is equal by dx is equal to 1 by x. So we can write this as the integration of this is e, and here integration of this log 1 by 1 plus x is log 1 plus x, but here we have negative sign, so we have to write this minus. Okay, so we can write this negative sign as -1. Okay, is equal to, so e -1 log 1 plus x. Okay, so here we have I is equal to this term. Now as we know, so a log b is equal to, we can write this term as log b power of a. Okay, so by this term we can write this as e log 1 plus x, and here in the power term we can write this -1. And as you know, in the exponential term we have, if we have log x, then we can write this as x term. Okay, so by implying this term we can write this as 1 plus x -1. Okay, so we can write this as 1 plus x. Now we obtain this if. Okay, if term. So we have obtained this if term. Now multiplying equation 3 by if. Here we have formula, that is v into if is equal to integration, then q into if dx plus c. Okay, so we have this term. Now as you know, we have v into if means we have obtained this 1 by 1 plus x, and in the q term we have ex 1 plus x, and in the if term we have 1 by 1 plus x and dx plus c. This and this cancel out, so we can write this 1 plus x is the integration of ex is ex. Okay, so constant term, so or b is equal to ex plus c and 1 plus x, as we have suppose v is equal to sin y. So therefore sin y is equal to e power of x plus c 1 plus x is required solution. Okay, so in this way we can solve this question.